Okay, now what do I do first? Let's see.
Hey Susan, what you doing?
Oh, I just unpacked this new AccuStasis 2000 with the printer calculator accessory. I'm starting to set it up. I've already gone through the accessory checklist and found everything I need.
Great. I used one of these on my last job. It's a nice analyzer, easy to use. Best of all, it gives reliable results. It's going to save you a lot of time and make your life easier.
Well, since you know so much about it, would you show me how to use it?
Oh sure, it won't take any time at all. I've got 30 minutes or so I can spare.
All right.
Okay, but before we actually set it up, let me give you an overview of the AccuStasis 2000. It will help make all the procedures you need to perform much easier.
Okay.
The AccuStasis 2000 performs a wide range of plasma clotting tests. It detects clot formations in two independent reaction chambers by a photo-optical method. In other words, a light beam passes through the cuvette holding the test sample and hits the photodetector. The photodetector continuously measures the intensity of the light beam, and as the clot forms, relays any changes to the electronic circuitry of the analyzer. Remember that as plasma clots, it usually becomes more cloudy or less clear. So you can actually follow the formation of a clot by seeing how much the light beam intensity changes. The analyzer measures the time required for the clot to form and displays the result in the LED window. If you're using the printer calculator accessory, the result is then printed out.
That makes sense, but how does the analyzer know when to start measuring the test time?
Good question. After you place the test sample into one of the two reaction chambers, push the reset button. This automatically zeroes the baseline and beam intensity, adjusting for the color and clarity of the test sample. When you add the start reagent with the pipette, the change in the light beam automatically causes the timer and stirring motor to start. This all takes place in the covered reaction chambers here and here.
Why is there a stirring motor?
The sample is stirred during the entire clot formation to ensure uniform mixing and to prevent settling of the components. The stirring action also creates a vortex, which keeps the developing clot directly in the path of the light beam. This optimizes both the sensitivity and the accuracy of the changing absorbance. You'll be able to detect even the weakest clot formations. This combination of stirring and light beam adjustments forms the basis of the photo-optical detection method.
How long does it take to finish a test?
Only a few seconds to set up a run and perform each individual test, but we're getting ahead of ourselves. Let's go ahead and get the analyzer set up while I go over the basic operating features. Looking at the AccuStasis 2000, you can see that it's divided into two major sections. The electronic display is at the top, while the control and testing portion is found at the bottom. The electronic portion, with the two independent electronic windows, will display your test results. The testing section is where the photo-optical components are located. Here, underneath the heating block, are the reaction chambers and the control buttons. There are 30 heated spaces, or dry wells, for incubation of plasma samples. Here is where your test reagents are kept in their heated dry wells, and this is where the covered reaction chambers are located. You use the various control buttons to set up and run your tests, then the calculated results are shown in the electronic display. It's very compact and easy to use. Let's turn on the analyzer and get started. We need to allow about 5 or 10 minutes for the analyzer to warm up. The display windows will show a series of small symbols in addition to the numbers at the very top. The symbols will change from minus to 37 degrees Celsius and finally to plus before equilibrating at 37 degrees Celsius. When the minus and plus are absent, you're ready to go. By the way, the photo-optical method employs a double baseline adjustment. When the cuvette is initially placed into the reaction chamber and the reset button is pressed, the first adjustment is made. When the start reagent is added, the instrument will readjust the baseline and lamp intensity up or down to compensate for clear or cloudy reagents. Place several AccuStasis disposable cuvettes with mixer bars into the incubation dry wells. Make sure there is only one mixer bar per cuvette. Any other number will cause errors in the analysis. The test reagents must also be warmed up for a minimum of 10 minutes. There are 4 heated dry wells for reagents here, 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 and here. This one, the larger well, also has a magnetic stirrer so that our test reagent can be stirred continuously. Now, many labs use the actual small Sigma reagent bottle as the reagent source. Other labs use the larger snap cap reagent vial when they are pouring off from the larger reagent bottles. In either case, it will be necessary to use the reducer ring, which comes in the accessory kit. Both procedures work equally well. So let's get the reagents ready for our first test, prothrombin time, or PT. Prepare thromboplastin according to the Sigma package insert, and add the clean Teflon-coated stir bar into the reagent bottle or snap cap vial. Now, place the reagent container into the left chamber. Don't forget the stir bar. This will stir the reagent continuously, making sure that none of the particles settle out. We're going to need calcium chloride for the next test method, so let's go ahead and get it warmed up too. We'll use the other chamber for that. Make sure the container is capped. Since we are using Sigma diagnostic reagents, it is very important that the PT test be performed with the sensitivity or send button pushed so the little red light is off. While the reagents are warming up, let's review proper pipetting technique. I can't overemphasize how important this is. While the AccuStasis 2000 is easy to use, you can really create problems for yourself if you don't follow the proper techniques. Go ahead and pick up one of the AccuStasis tips and take a close look at it. It has 3 key features that were designed to reduce the problems commonly found with other manufacturers' tips. Notice that it has a larger bore, is slightly shorter, and has a special shoulder to help guide the tip to the correct position in the cuvette.
I can see how the shoulder helps me, but what about the length and bore?
If the tip is too long, it might break the light beam and accidentally start the stirrer motor as you're injecting the plasma or reagents. Also, if the tip remains in the liquid after delivery, it's easy to withdraw some of it when you remove the pipette. That creates inconsistent delivery volumes, which of course gives you inaccurate clotting times. The larger bore has a greater reserve airspace between the liquid and the barrel of the pipette. Therefore, the barrel is harder to contaminate, and you don't have to spend extra time cleaning it. The larger bore essentially eliminates excessive foaming due to rapid pipetting. Foaming can easily lead to errors and inconsistent results, so just use a moderate pipetting speed. You won't have any trouble with foaming. You see, the AccuStasis tips are part of the overall AccuStasis 2000 system. It's been designed to integrate all the various parts into a logical and consistent whole, so you spend less time testing and produce better results. The cost savings and high degree of accuracy definitely make this a winning combination. Besides paying attention to the tip, it's also important to properly use and maintain a good quality pipette. This is not the place to try to save a few bucks by using a cheap one. When delivering the liquid, make sure to hold the pipette in a vertical position to avoid causing any materials from entering the barrel. I can't overemphasize how important it is to keep the pipette in a vertical position at all times when you're transferring liquids. If the pipette does become contaminated, remove the nozzle insert and clean the barrel according to the manufacturer's directions. You know, it's amazing how many people use the pipette and then tip it and never realize they've contaminated the barrel.
You're right, and then they can't understand why their results vary so much.
Good preventive maintenance always saves time and trouble. I'm glad our lab pays so much attention to it. Another error to avoid when using the pipetter is setting incorrect delivery volumes. It's easy to select the proper volume by simply rotating the plunger button until the appropriate volume number is positioned next to the black indicator line. That reminds me, it's also necessary to periodically validate or confirm the delivery volume of the pipette. I know that the process takes a little time, but it's so important that it has to be done, and done carefully. Just check the pipette instructions for the validation instructions. Don't we check ours once a quarter?
Yes, that's right. Okay, I'm ready to run my first test.
Good. Why don't you put on your gloves and I'll get the safety goggles. Now, using our calibrated pipette, place 100 microliters of patient or control plasma into the center bottom of the cuvette. It's important to avoid touching the sides or actual bottom of the cuvette with the tip. This eliminates liquid from adhering to the side of the cuvette. Fluids lost in this way can lead to significant errors. Remember, the special shoulder will help guide you as to depth and position. And don't pipette too fast. Of course, we'll be sure to run duplicate test samples. That's where the second reaction chamber can be so helpful. Imagine running 2 tests at the same time. You can time the incubation period by pressing the Start button of either channel. Push the Reset button on the same channel to stop the timer. Gently but firmly tap the cuvette on the tabletop to dislodge any bubbles that may be trapped at the bottom of the cuvette. Allow the plasma to warm up for at least 120 seconds, but not more than 300 seconds. Now that at least 120 seconds have passed, take your first patient or control plasma in the disposable AccuStasis cuvette and place it in the reaction chamber. The cover on the chamber slides toward the rear of the analyzer to facilitate cuvette placement. Press the Reset button. The baseline and lamp intensity will automatically adjust for the clarity and color of the sample. When the 0.0 reappears on the display, you are ready to add the pre-warmed thromboplastin, or the start reagent. This should take about 2 to 3 seconds.
Okay.
Now go ahead and add the start reagent. Pipette 200 microliters into the test cuvette, holding the pipette vertically in the pipette guide. The sudden change in the intensity of the transmitted light beam will automatically trigger the digital test timer and mixer motor under the reaction chamber. The mixing motor creates the vortex and immediately mixes the plasma and thromboplastin. During the first 2.5 seconds of mixing, a second lamp adjustment takes place. Afterwards, the mixing and timing continue until a clot is detected. Then the mixing motor and timer automatically stop as the clot time is shown on the digital display. We'll be using the printer calculator in a little while, but right now just write down the time result in your test log and you're ready for the next test. Remove the used cuvette from the reaction chamber and dispose of it properly. Now that I've walked you through this once, why don't you run the duplicate?
Okay. Since the sample is still within the incubation time window, I can put the duplicate in the reaction chamber and close the cover. When I press the Reset key, the double baseline adjustment takes place, then 0.0 appears in the LED display window. Now I'm ready to add the 200 microliters of warm thromboplastin to start the reaction. I'll make sure I hold the pipette vertically in the guide. All right, both the timer and mixer started. So the process will continue until the clot forms and automatically stops the mixer and displays the clot time in the LED display window. Wow, that was easy.
The next test you need to learn is the activated partial thromboplastin time, or APTT. The procedure is very similar to the PT test, but uses a smaller volume of reagent, has a longer total incubation time, and requires the addition of calcium chloride. You're also going to use both reaction chambers or measuring channels this time. I'll talk you through it while you perform the first test. Once again, place several AccuStasis disposable cuvettes in the sample incubation wells. Make sure there is only one mixer bar per cuvette. The Sigma APTT reagent is liquid and ready to use. Place the reagent bottle or snap cap vial in the heated incubation block. Remember, we put our capped calcium chloride in the right side incubation well earlier, so it's already warm. We want to make sure the SEN button is pushed so that the red light is off, so make sure that's the case. All right, now pipette 100 microliters of patient or control plasma into the center bottom of the cuvettes and incubate for 60 seconds. This is the first incubation stage. Remember, it's important to avoid touching the sides or actual bottom of the cuvette with the tip. You can time the incubation period by pressing the Start button for each channel. When the timers reach 60 seconds, go ahead and pipette 100 microliters of the pre-warmed APTT reagent into the pre-warmed cuvettes that contain patient or control plasma. This is the start of the second stage incubation period, which must be 180 seconds long and within 15 seconds of each duplicate. Remember to gently tap the cuvettes to remove any air bubbles. Let the timers continue until they reach 240 seconds or 4 minutes. Then you start testing the samples. While we're waiting to incubate to 240 seconds, let me explain how we'll perform the next steps. Remember, in the prothrombin time test, your total incubation window was 120 to 300 seconds, so the incubation periods could vary quite a bit and still give consistent results. However, in the APTT test, the second stage incubation times for the duplicates must be 180 seconds and within 15 seconds of each other. The only way to ensure that degree of accuracy is to use both channels for timing and testing. Let me explain. Once the timers reach 240 seconds, you'll place each cuvette in its reaction chamber and immediately press the reset buttons. Then you'll add the calcium chloride to start the reactions, and the analyzer will do the rest. Okay, we're almost up to 240 seconds. I'll talk you through it. You just follow the steps. That's right, place each cuvette into its reaction chamber, close the cover, and immediately press the reset button for each channel. After the automatic baseline adjustment has finished, 0.0 will reappear in the electronic display windows, and you're ready to add the start reagent, or calcium chloride. Go ahead and pipette 100 microliters of the pre-warmed calcium chloride into each test cuvette. Notice that both the timers and the stirring motors automatically start. Once the clots are detected, both will stop, and the clotting times in seconds will appear in the electronic display windows. Great job! Now you're ready to continue on and test the duplicate and the rest of the samples. You'll be done in a few minutes, and then I'll show you some simple maintenance tips and basic troubleshooting.
We've sure covered a lot of ground in the last few minutes.
Yes, we have, but it all makes sense. And this AccuStasis 2000 will do much more than just these routine tests. Because the photo-optical clot detection principle gives it the capability to measure weaker forming clots, other tests such as factor assays, thrombin times, heparin assays, and antithrombin 3 are all possible to perform. The Sigma Diagnostics Technical Service Team can help you with these tests or any other questions on their toll-free 800 number. Do not add any materials into the reaction chamber unless a cuvette is in place. If any liquid is accidentally added, clean the chamber with a soft tissue. Do not use any cleaning agent that contains alcohol. Always cover the instrument with a dust cover when you're done for the day. The fuses are located on the rear panel of the analyzer. Before changing any fuses, make sure you turn off the instrument and unplug it from the electrical service. To change a fuse, use a small flat-bladed screwdriver to snap open the cover over the voltage selector. To the right of the voltage selector are two small black tabs with white arrows printed on them. Use the small screwdriver to gently pull each fuse holder out and replace the fuse. Slide each holder back into place, snap the cover closed, and test the analyzer for power. It's very unlikely that the light source or the photodetector will fail, but if one does, please do not attempt to replace it yourself. Immediately contact the Sigma Technical Service hotline for further instructions. One of the really strong points of the AccuStasis 2000 system is its reliability and simple maintenance. If everyone always followed proper technique, this system would be virtually trouble-free. But you know that most of us get in a hurry sometimes and either cut corners or just don't pay enough attention to the details.
Well, what types of problems tend to occur?
Mostly they fall into three areas: proper handling of reagents, following appropriate incubation times, and using careful pipetting technique. Of course, if you thought you had a problem with the analyzer, you should go through some basic troubleshooting before you call the Sigma Technical Service hotline.
What kinds of clues would indicate I might be having a problem?
Good question. Let me highlight a few situations that would indicate a problem might exist. Then you would refer to the operator's manual for detailed suggestions on what steps to take. If you're still having a problem, then be sure to call the Sigma Technical Service hotline for immediate help. A difference of more than 5% between duplicates. Tested values are different than normally expected values on controls and patients. The timer stops sporadically during analysis. The timer stops at 5 to 7 seconds, and the display may indicate an error message. The timing and mixing does not begin after the addition of the start reagent. The timer does not stop after a reasonable amount of time. Remember, you would refer to the operator's manual for detailed suggestions on what steps to take. If you're still having a problem, then be sure to call the Sigma Technical Service hotline for immediate help.
I have just 2 questions concerning this printer calculator. What does it do, and how do I connect it?
Okay, I'll show you how to assemble and attach it to the analyzer. Then I'll explain how powerful and useful this accessory is. Now, we have to combine the 2 modules and then attach the cables. The smaller module, which is the printer, simply sits on the calculator. See the 4 alignment holes? Just line them up, and now you have a single unit. The cables are real easy to figure out. Just make sure the power switch is in the off position and that you attach the AC cable last. But before we connect any cables, look at the back of the printer module. There's a series of 8 dip switches which need to be checked. All of the switches should be in the up position except number 5, which should be down. Go ahead and check them and tell me how they're set.
Just like you described. So I'm ready now to attach the cables, just like it shows in the manual.
That's right. Now be sure to remember to turn off the AccuStasis 2000 before connecting the printer calculator accessory. Okay, we're ready to turn the printer calculator unit on, which should make the power indicator light glow. Now we can turn the AccuStasis 2000 back on. We've already put paper in the printer, so let's program a few simple variables in the calculator and we'll be ready for further testing. I'm only going to explain the basic operation now. You can read any additional procedures in the operator's manual. Often, operator's manuals can be confusing. This one is surprisingly well written, but it is very important that you follow the instructions carefully, because if you go start pushing keys on your own, you might enter a screen and not be able to get out. If that happens, just unplug the printer calculator and start over.
Good, that's helpful.
Did you hear that beep when we plugged in the AC adapter? That tells us that it's on and ready to be programmed. The time and date come preset, but we need to check them just to be sure.
That's right, daylight savings time might have changed.
Or leap year. Now, if we need to change either, it only takes a second. Press the F or function key followed by the 3 key. The time and date appears for a few seconds. Note the format. The time uses a 24-hour and minute style, while the date shows day, month, and year. If you do need to change the time, press the F key followed by the 1 key. Use the left or right keys to move to the digit that needs to be changed. Notice that as you input a new number, the cursor automatically advances to the next digit. This very helpful feature is found in all the programming screens. When you finish setting the time, be sure to complete the process by pressing the F key. Next, set the date if necessary by, again, pressing the F key followed by the 2 key. Remember to hit F to finish the process. Good. You can always display the current time and date from any screen by just pressing the F key followed by the 3 key. Now we're ready to set up our PT test method and INR reporting mode. The printer calculator offers 5 tests accessed in the Method menu. Press the M or Method Selection key, and you'll see a single word or abbreviation on the screen. Use the up or down arrow keys to scroll through the 5 tests. Locate the PT test screen and press the M key again. The display should now read 1 PT SEC 0.0 and is called the Measuring Mode screen. Let me briefly explain what these items represent. The printer calculator is capable of storing data from 2 channels. Remember, the AccuStasis 1000 is a single channel analyzer, while our AccuStasis 2000 has 2 measuring channels. The printer calculator identifies whether you're recording channel 1 or channel 2. So we have to select which channel we're recording. Okay, the PT is the test we've selected. SEC means our results are to be reported in seconds, and 0.0 indicates that we're ready to receive data. Okay, now press the CAL or calibration key. A cursor will blink on the first entry space. That shows you where to enter the incubation time in seconds. Do you remember how long to incubate your samples and reagents for a PT test?
Yes, you allow at least 120 seconds, but not more than 300 seconds.
Right, so type in 120. Again, notice that the cursor automatically advances each time you type a digit. Press the down arrow key. The cursor now wants you to enter the 7-digit reagent lot number. Look on the side of the reagent vial. If it contains a letter, just count the corresponding number of the alphabet and use that. In this case, the lot number is 3H142. So type in 003H. A, B, C, D, E, F, G, H. So H is an 8, then type 142. Good, but remember that when you change lots, you must go back and reprogram this step so that your printout will be correctly labeled. Now hit the down arrow key again. This is the reporting method entry screen. There are 3 choices you can select: ratio, INR, %. Use the right or left arrow key to bracket the reporting unit you want. Go ahead and select each one just for practice. Notice that each time you select a reporting unit, it turns to all capital letters, and arrows are on each side. Now, currently, our lab is reporting test results in ratio, but the doctors want to be able to report in International Normalized Ratio, or INR. That's one of the reasons we bought the AccuStasis printer calculator accessory. Not only can it report in INR, but it will also calculate ratio and print out all the results, including seconds on paper.
Wow, that will really make my job easier and give the doctors all the information they need. Everybody wins.
Right. Now go ahead and select INR, because we have a few PT steps left to program before running some more tests. Okay, press the down arrow key and the 100% reference value screen is displayed. Again, the cursor is blinking because you need to input the 100% reference value. That's the median test time of your lab's normal patient population. The value of 12.0 seconds is pre-programmed, and we can use that for today, unless you know our lab's actual value. Press the down arrow key again. This displays the ISI value screen. You find the correct ISI value in the package insert of your sigma thromboplastin reagent. The blinking cursor indicates we need to input this value.
Here it is, 2.45, and I'm done.
Not quite. You need to return to the PT measuring mode screen so that you can receive data from the AccuStasis 1000. How would you return to that screen?
Let's see, I entered this series of screens by pushing the cow key. So I would press the cow key again. All right.
Good. The cow key stores all the values you set and returns you to the measuring mode. Let's run a PT test and then print out the results.
By the way, what happens if I unplug the printer calculator at night or if I need to move it?
No problem. There's a continuously charged battery that keeps all the stored data in memory. Okay, now that we've finished the tests, we can send the data for conversion and printout simply by pushing the % button on the AccuStasis 2000 control panel. It's critical that the printer calculator be in the PT measuring mode so that it can receive data from the 2000. Go for it. Look at the paper printout. It contains more than just the test results. It also prints the test method, the time and date, lot number, 100% reference value, ISI value, and then the test results reported as sample number, channel, PT time in seconds, ratio, and INR. There won't be any numbers under %, just X's because the curve is zeroed out. There's even a space for the patient's name or number. This printer calculator accessory really makes data reporting a breeze and reduces the chances of transcription errors. That helps everybody. Let's go to the APTT measuring mode screen and set a few quick parameters. Then we'll run some APTT tests and print out the results.
Okay.
Since we're going to set up a new test, we need to go back to the method menu. Can you remember how to do that?
Let's see. I need to select a new test, so I would use the M or method selection key. That puts me in the PT method. Then I use the up or down arrow key to scroll through the test until I come to the APTT method screen. Pressing the M key one more time puts me in the APTT measuring mode screen.
Good job. Since you're going to set new parameters for this test, which key accesses screens to set or change values?
The cal or calibration key. All right. The incubation time screen comes up first with all zeros and a flashing cursor. I need to input the incubation time for the APTT test. Let's see, that was 180 seconds. So I type 180. That's right. The cursor automatically advances. How simple. Next, pushing down the down arrow key, I get the lot number screen. Once again, I type in each digit, 003H. Oh yeah, I have to convert letters to numbers. A, B, C, D, E, F, G, H. So H is 8, then 1, 4, 2. Now, I'll press the down arrow key again. Nothing happened. What does that mean?
It means the calculator is pretty smart. Remember, when you've programmed all the screens, you're at the bottom of the menu. You got there by using the down arrow key. So you press the cal key to store all the values you set and return to the APTT measuring mode screen. On page 10 of the operator's manual, you'll find a menu tree or flowchart of all the printer calculator menus and how to navigate from one to the other. Once you practice with the calculator a little bit and refer to the menu tree, it will be simple to operate. Of course, if you have a question or problem and need help, you can always call the Sigma Technical Service hotline at 1-800-325-0250 for further information. Okay, run those APTTs and send the results to the printer calculator. Remember to place the printer calculator accessory in the APTT measuring mode so that it can receive the data, and then hit the Start key on the AccuStasis 2000 to send the data. Good, it's printing. When it's done, we'll look at the results. Tear off the paper and tell me what it says.
It shows the method, time, date, lot number, sensitivity off, test number, channel, test results in seconds, and a space for the patient's name. All right, I like this.
That about covers it. Let's go to lunch. You can treat me for all this free help.